Good afternoon, good morning. Welcome to Notes 7.01, Special Right Triangle. So there's two types of triangles we're going to talk about today. This is a pattern formed with a 45, 45, 90 right triangle or an isosceles right triangle. Okay. And then we also are going to have a 30, 60, 90 right triangle, which is always scalene because all three angle measures are different. But there's always a small angle of 30 degrees, a larger angle of 60 degrees, and then a 90-degree angle. So they all add to 180. So there's two special cases called the special right triangles. So question one, and we saw this a little bit in our notes the other day. We use the Pythagorean theorem to find the value of x in simplest radical form. Here we have sides of 3 and 3, and we're asked to find the hypotenuse x. So again, since it's a right triangle, we can say that 3 squared plus 3 squared equals x squared. Now, when we square each of these and add them together, we're adding two perfect squares together. So we get 18 equals x squared. But when we go to reduce that radical, it's always the sum of the two perfect squares we just had. So there's two things added together and they're both perfect squares. We get 9 two times will become 3 square root of 2. So when these sides are 3 and 3, the hypotenuse ended up being 3 radical 2. So that's the pattern here that's formed. Whatever these two sides are goes out in front of our square root of 2 because we're adding that same side twice as perfect squares to then simplify out that same perfect square. So the pattern that we talk about for the 45, 45, 90 right triangle goes like this. X is across from the first 45-degree angle. Then x is the same measure across from the other 45-degree angle. And then across from the 90-degree angle is not 3. If the sides were 3, then it'd be 3 radical 2. But in our case, it's going to be x times radical 2. So x is the measure of either of the sides, and x square roots of 2 is always opposite the 90-degree angle. So when I talk about standing opposite an angle, that's going to be very important for us. So again, if these are the equal sides, meaning these two angles are 45 degrees and 45 degrees, because in an isosceles triangle you have two equal angles, okay? If that's 45, the side opposite the 45 is a measure of x. So 45 to x, 45 to x, 90 to x radical 2. So again, if each of these sides were 1 and 1, this is 1 square root of 2. If I change this to 11, that would be 11 and 11 and 11 square roots of 2 is how we kind of set these up. So looking at a couple examples, exercise 2, find the missing side using the 45, 45, 90 rule. This side is 9, right? It's opposite the 45-degree angle. That means this other side is going to be 9 because it's isosceles. So y will be 9. And x will be 9 square root of 2 using our rule. So across from the 90-degree angle is the hypotenuse is this side times the square root of 2. Looking here, if this side is x, this side is x. Okay. Well, our rule goes 10 radical 2. This hypotenuse, again, is x square root of 2. So if I write x radical 2 above that 10 radical 2, we're going to identify that x is simply 10. So in this side, each of these sides are going to be 10 and 10, so that the hypotenuse is 10 square roots of 2. Again, that's just the pattern here form. So again, we knew this was an isosceles right triangle, making these two angles 45, 45. So each of these matching sides are 10 and 10. Letter C is a little bit different. I'm going to write in the rule. This side is x, this side is x, this side is x square roots of 2. Okay. So it's easy to find the two equal sides here and here. So again, if this is 45, we know here is 45. Okay. So that these two sides match. So if our x value is 3 radical 6, then this side is 3 square roots of 6, because those two sides are going to match. It's isosceles. The hypotenuse is x times the square root of 2. So I'm going to put in 3 radical 6 times the square root of 2. Now, a little lesson we skipped over doing for today's, or maybe you did 701 before you did 701A. Okay, 3 square root of 6 times radical 2, we have to talk about multiplying those. So 3 square root of 6 times the square root of 2 becomes 3, and we multiply these radicands together. So the two numbers underneath now become the square root of 12. Well, that's not simplest radical form. Okay? So from here, we have to simplify. So 3 squared to 12 reduces to 4 and 3 from our lesson the other day. Square root of 4 becomes 2. 3 times 2 gives you 6 square roots of 3. Ooh, I said 3 and I wrote 6. That's my mistake. So this hypotenuse is 3 radical 6 times the square root of 2 becomes 6 square roots of 3 as the hypotenuse. We could have put in these two radicals and the Pythagorean theorem and worked it out that way, but this is a little shortcut where you take the x value that either of the sides are and you multiply it by the square root of 2. We're going to do some more of those on the next page. The other rule is our 30, 60, 90 right triangle. And how this rule goes is 1, radical 3, and 2. That if this side is 1, which is opposite your 30-degree angle, okay? So across from your 30-degree angle is a measure of 1x. Across from your 60-degree angle, okay, across from, meaning if I'm standing here and I'm looking out, I'm going to hit that radical 3 side. These two sides meet to find that 60-degree angle. So we're not talking about these two measures, but across from 60 is your square root of 3. That's going to be x square roots of 3. And across from the 90 is 2x. So again, across from 30 goes 1 times the measure of x. And again, these are proportions. So x kind of increase is your scale factor in these cases. Across from 60 is x times the square root of 3. And across from 90 is 2 times x. So that's in a ratio. 30 goes to 1x, 60 goes to x squared to 3, 90 goes to twice x. Now, those three measures, the 1, radical 3, and 2, are in order mathematically. 1 is equal to 1, right? The square root of 3 is a little bit bigger than that. And 2 is obviously bigger than that. So 1, 1.72, those numbers go in order. 1, 1.72. So you're really taking 1 times some value of x, some scale factor. You're taking 205 times some scale factor x, and 2 times some scale factor x. Now the 1 goes across from the 30, the radical 3 goes across from the 60, and these go in increasing order, and 2 goes across from the 90. That might help you decide what goes across from each. Okay. So in the figure below, x is the shorter leg. Then use the Pythagorean theorem to find y in simplest radical form. So using our rule, across from the 30-degree angle is 1 times x. Across from your 60-degree angle is x times the square root of 3. I'm going to just cross out the y for a second. And across from 90 is 2x. Well, the only measure that was given to us on those three sides is this 10. So we know 10 is equal to twice x. So twice x equals 10. That makes the scale factor here 5. So if x is 5, then this side is a length of 5. And that means the third side, if x is 5, then this third side is 5 times square root of 3. It's going to be 5 radical 3. So magically, how that just worked, if you missed it, this side is 10. The shorter leg is half of that measure. So this is always equal to 2x. Then the shorter side's got to be 5. Across from that 60-degree angle, the longer leg. So again, this one's a little bit longer, so we got to take 5 and multiply it by radical 3. So by only knowing one side of the picture, that was the only given information besides the angle measures. Okay, 30 there and 60 here. That was the only given here. We were able to find the other two sides without the Pythagorean theorem or anything else, just this little rule. So we're going to do a couple more. Have you catch on? Okay. So across from the 30-degree angle, I'm going to write 1x. Okay. Across from the 60-degree angle, I'm going to write x radical 3. So we're trying to find that measure. Y is just a new variable to say that these two things are of different measure, right? And across from the 90-degree angle, we're going to put 2x. So 1x, x radical 3, and 2x I put across from each one of those three measures. Okay. So if we only are given this 22, so 2x equals 22, that gives us that x is 11. Well, if x is 11, that means this side is 11. Because that side is 1 times x. This side is that x value of 11 times square root of 3. So this side is going to be 11 radical 3. So again, I was given the hypotenuse, and I was able to find the other two lengths. And we can verify these lengths into the Pythagorean theorem. 11 squared plus 11 square roots of 3 squared equals 484, which is equivalent to our hypotenuse squared. 22 squared is 484. Okay. Same thing up here. I tested these three measures, 5 radical 3, and 10. 5 squared plus 5 square roots of 3 squared gives me 100. Okay. So again, I was only given one known measure. I was able to find the other two sides of this Pythagorean theorem right triangle. So looking from this 30-degree angle, we know the third angle in the triangle is going to be 60. Across from the 30-degree angle is 1x, making x to the 5. Okay. So in this question, x equals 5. So if x equals 5, we're trying to find these two sides. I'm just going to put question marks there. I don't want to confuse you with the other x's, okay? Across from the 90-degree angle is going to be twice x. Well, twice times 5 is going to give me 10. So 2 times my 5 value is 10. So now I know this side. So again, I was given one measure. Knowing it's a 30, 60, 90 right triangle, if that's 5, this becomes 10. Well, across from the 60-degree angle is x radical 3. Well, if x is 5, I'm going to put a 5 in for the x. So we get 5 squared to 3, 5, which happens to be this picture. It's just rotated upside down to really mess with you. Moving on to the next page, you're going to practice a bunch more of these. And then putting it in a little bit different format. So looking here, we have practice, use the special right triangle rules to find the missing side. Answers must be in simplest radical form. So again, your 45, 45, 90 right triangle is x, x, x square roots of 2. Okay. Now there's only two measures really there. 45 repeats itself, and 90. That's how we remember this radical 2 goes with x squared to 2. It's because there's only 2 digits within those three angle measures. All right. So across from the 45 is side x. So across from the side angle L here is going to be little side L is going to be x value. Across from the other 45-degree angle, now if this is K, this is little side K. Okay, so remember capital letters represent angles. Little letters, this is little pi, is also going to be side x. So x and x are our two legs. And across from j, it's going to be little j, is represented by x square roots of 2. So here we're talking about 4 different triangles. So I'm trying to give you 4 separate problems. If side k, which is one of the little sides, side L is a little side, J is the hypotenuse, x square roots of 2, okay? 17 is this side here. So if I take a pencil, we're going to do 4 different triangles here. But if this side is 17 for triangle number 1, then the next side is also 17. And the hypotenuse, if those are my x values, the hypotenuse is 17 times square root of 2. I'm going to do the first 2 for us. The next little case is triangle 2. So we're forgetting about the 17 for a second. So side K for triangle 2 we have to find. But side L we know is 3 square roots of 5. So back over here on the triangle, I'm going to put that this side is now 3 radical 5. Well, this side is 3 radical 5, then this side is going to be 3 radical 5. So little k is going to be 3 square roots of 5. Okay? So again, these two sides should always match. But the hypotenuse is that measure times the square root of 2. So we're going to put in 3 radical 5 times the square root of 2, because that's our x value times the square root of 2. Now to simplify this, remember we multiply the radicands. So 5 times 2 becomes the square root of 10. And our 3 pulls down in the front. That's what we're looking for. Okay. So these two measures will match. Here, you take that side and you multiply it by the radical 2. Now this side, to move backwards, we don't multiply by the square root of 2, but we divide by square root of 2. Okay? And a little division practice, 3 radical 6 divided by radical 2 gives you, well, 6 divided by 2 is 3. Is 3 square roots of 3. It's going to be these other two sides. So I did triangle 4 with you. I'd like you to finish up triangle 3 column to submit for work today. Letter B. We're going to practice the 30, 60, 90 right triangle. So across from the 30-degree angle, remember is side x. Across from the 60-degree angle is x times square root of 3. And across from the 90-degree angle is 2x. I'm going to move this over just a smidge. X radical 3. That's what I meant to put the cross AC here. So 30, 60, 90 is x, x radical 3, and 2x. Now these are 3 different digits, right? 30, 60, and 90. That's how you can tell that the square root of 3 goes with 30, 60, 90. Right? So if you want to draw out this triangle a few times and do each of these pictures a little separately, maybe that'll help you. I'm trying to make them all look the same here. So the longer leg is on the bottom. So we have the short leg, we have the longer leg, and we have our 90-degree angle. Right? Now, across from the 30-degree angle is x. Across from the 60-degree angle, now this picture is not drawn to scale, is x radical 3. And across from the hypotenuse is x. So if side A is across from our 30-degree angle, that's going to be a measure of x. Now side B is always across from our 60-degree angle, so that's going to be x times radical 3. Well, if our x value is 3, then 3 radical 3 drops in. Now, across from C, across from our 90-degree angle, is twice x. So if x is 3 for this first triangle, if this is 3, Then this side is 3 squared roots of 3. And then this side is 2 times 3 is going to be 6. So I want you to use that pattern to kind of go through the rest of the table here. So if your x value is 2 squared roots of 3, then that's going to go in front of this square root of 3. And you can simplify. So 2 squared roots of 3 times radical 3, and kind of follow. Same thing here. 2 radical 6 is your x value times the square root of 3. I'd like you to simplify those radicals. Down here is twice x. So you're going to put 2 times your x value and simplify what you can. Moving backwards, if this is 2x is 8 for your c value, if this side is 8, then across from your 30-degree angle is half of that measure. And then this side, if you know your 4, you'll know what to do for the middle measure. So again, this is kind of filling in the pieces. Try what you can there. I want you to fill in the blanks. Again, this little bucket here is the number that goes inside of it. Same process there and there. Question number 6, I'm going to help you draw out the pictures and understand what pieces we're talking about. Same with 7, you're going to try on your own. So looking at question number 6, triangle RAT has a 30-degree angle at R, a 90-degree angle at A, so I'll know that this one's A, and 60-degree angle at T. Now, angle measures and sides have a ratio, okay? If I have a small angle, I connect with a short side. If I have a larger angle, so this little angle compared to this angle here, I connect with a long side. So this to me looks shorter than this one, okay? Which means this angle is smaller. So this is going to be my 30-degree angle, R, and that makes RAT my 60-degree angle is here. Okay? So that across from 30 is side little r, which is 12. So side r is 12. We'd like you to find side AR. I'm going to put a question mark here. And side over here is your hypotenuse. So if I talk about 30, 60, and 90, x radical 3, across from your 30-degree angle is your value of x, 12. So if you substitute those pieces, knowing x to be 12, x radical 3, and 2x, you should be good to try question 6 and finish up 7 on your own.